So again, the first thing you want to do with your Spec 20 is you're going to use the 0% T knob, and you're going to adjust the 0. Okay, now you notice that if I open up the hatch here, it doesn't do very much. Okay, because there's a little spring that goes down in front of the light path. Okay, and so in order to get this one to work, then I have to have a cuvette, which, now they were out, they were here. Okay, that's a test tube, that's not a cuvette. Okay, no, that's, we need a round one. What happened to it? Oh, well, here's some over here. There, we're going to have to go find them. Okay, so this is the cuvette you're looking for. It has a little line on it. Okay, and so we can fill this with water. And the line is meant to fit this line on the gadget here. You've all seen this before. And then what I'm going to do is I'm going to adjust the 100% T knob, and that will get everything on scale. All right, now for this instrument, what I have to do in order to get the 0% is you have to pick this gadget up, and you see the light path, when it's down all the way, goes this way. Okay, so I can pick it up, turn it 90 degrees, put the top on, and then I can set the 0 adjust, which is on the other side. Okay, and you do the same thing this way. Now, then I can take this, and then we have to find a cuvette for this one. This is going to be a problem. Here we go. Now, remember Dr. Al was talking in the lecture? This one has a 1 centimeter inner diameter path length. This is bigger, about 1.6 centimeters. Okay, so in this case, I can again fill it up, and if you pull this out, you know, you can see it's only the bottom half, okay? And so you just need to fill this about halfway. So in this case, I got the thing set, and now I'm going to set this, and now I can set either the coarse or the fine in order to get the 0, okay? Now, again, just like this one, and just like in quant, you want to record in %T because it's linear, okay? And you look at the log or the absorbance plot, and it's not, it's logarithmic. How come is that? Why is that? Okay, how do you calculate absorbance from %T? It's written right here, okay? All right, it's 2 minus the log of the %T, right? There's the log, and that's why it's logarithmic, okay? And so the only really good way to calculate the absorbance is just to calculate it on Excel. Okay, so you know, if you get the %T, you're good. All right. Each of these has a lamp, a grating, and then a path length and a detector of some sort. Now the grating, of course, is just nothing more than a piece of flat glass which has mirrored glass, which it has little tiny lines on it. Okay, and as you rotate that up and down, okay, it will break up the colors of light into all the colors of the spectrum. Okay, and you set the angle of the grating with the wavelength knobs, okay? And so then they're correlated like that, and you can go on from there. But, okay, what you want to do is you want to set this one to 400. That means I'm going to have to reset it. And this is the big take-home thing about spectrophotometers. The spectrophotometer detector, I think this one has something like a barrier detector, if I remember correctly, and this one has a little photo multiplier tube, so they're completely different kinds of detectors, all right? So each of these things has a sensitivity to light at different wavelengths that is different, just like we do. Okay, so when I go out, it gets really dark, or maybe the light, is red or blue. If you drive in your car and you have dash lights that are red, okay, then everything kind of looks flat. Okay, so our eyes don't detect deep red very well. Okay, we also don't detect infrared or ultraviolet light very well unless you have had your corneas removed or your lenses. Okay, it used to be that the cure for cataract is to actually take out the lens. Now what they do now is they put back a plastic lens, which means you can't see in the ultraviolet. But before, people who had the cataract surgery could actually see into the ultraviolet because the lens actually absorbed the ultraviolet light. Okay, now that also means that there are cutoffs. Okay, glass will not transmit infrared light. Okay, and it also will not transmit ultraviolet light above about 250 nanometers. Okay, it just absorbs it all, and that's the end of it. Okay, so you can get further into the ultraviolet by using quartz, and so we have some quartz cuvettes over there that can be used to get further about down to 220, and then it cuts off. Okay, so that's the kind of thing. But now, so there are different levels of response at different wavelengths, and I can show you that simply by starting to turn the lever. And look there, it goes offline right away. And then it goes down, it goes up again. Finally, I'm going to get to these red marks, and of course that means you flip the little lever. And then I can go down and look, it's pegged. Okay, so what if I turn this down, okay, and start moving it around? It's going to peg again. Let's go down to 400 nanometers again and flick that over. I'm going to actually turn this down a little bit more. And you can see as I turn the wavelength, first it goes down. Okay, I can maybe get this down a little bit. Okay, so I'm going to go back to 400. Okay, so it goes down a little bit. Now look, it's climbing. I'm going to flick that. And then I can go up to 700, okay? And you can see that it swings. So this instrument doesn't see all wavelengths the same. Okay, so I'm going to turn this one up all the way to 100%, okay, and go back down. And then I have to flip the line. And then I'm going to go down to 400, and hopefully it will all stay on scale. And so it does. Okay, I've just done part A. Okay, part A is to be able to get the entire sweep of this spectrum on one scale. And how did I do that? I just started turning it, and whenever it pegs off, I turn it down a little bit. And I keep going there. Now, at this point, I could start at 400 and start writing these numbers in, and you can only have to do it once because you won't screw up. Did everybody see how that worked? Kind of. Yeah. Okay, yes. You do the same on this one. It's exactly the same. So for instance, I'm going to set this one down to 400, okay, which is its max. And then I'm going to go up and I'm going to see now. You notice it goes up here, it goes up. Oop, I pegged it out. That means I'm going to turn it down a little bit. Going up here to, okay, it starts to go down a little bit. There's 650, there's 700. Okay, so I've got a max. In other words, this instrument is most sensitive around 600 nanometers. So what color of light is at 600 nanometers? It's in the red, yes. Okay, so I can take this one, I can maybe turn it up a little bit, and that's going to be the top of my, oops, kind of went a little further. Okay, that's the highest. So I'm going to turn that back down. Okay, and as I move this around, I'm going to go down to 400, and everything's on scale. That's part A done. Okay, so now you can start to go and start to record these things. So now let's go over to the board.